You are welcome. Online resources offer valuable learning experiences about electrical theory and other topics. Continuous learning and asking questions are important aspects to becoming a skilled professional. Don't hesitate to seek information. Electrical theory is a fundamental aspect of understanding how electrical systems work. It provides the foundation for designing, analyzing, and troubleshooting circuits and electrical equipment. A strong understanding of electrical theory is essential for anyone working in the electrical field, including electricians, engineers, and technicians. Electrical theory encompasses a wide range of topics, including basic circuit concepts, electromagnetism, alternating current circuits, and power systems. Understanding these concepts is crucial for designing and analyzing electrical systems. Firstly, basic circuit concepts involve understanding voltage, current, and resistance, which are the fundamental building blocks of any electrical circuit. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It drives the flow of electrical current. Current, measured in amps, is the rate of flow of electrical charge through a circuit. Resistance, measured in ohms, opposes the flow of current. Ohm's law describes the relationship between voltage, current, and resistance, stating that voltage equals current times resistance, or volts equals amps times ohms. Secondly, series and parallel circuits are two basic types of circuit configurations. In a series circuit, components are connected end to end, so the current is the same through each component. The total resistance of a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, so the voltage is the same across each component. The total resistance of a parallel circuit is less than the smallest individual resistance. Kirchhoff's laws are fundamental principles for analyzing electrical circuits. Kirchhoff's current law states that the sum of the currents entering a node or junction in a circuit must equal the sum of the currents leaving the node. Kirchhoff's voltage law states that the sum of the voltages around any closed loop in a circuit must equal zero. Thirdly, electromagnetism is the study of the relationship between electricity and magnetism. A magnetic field is created around a current-carrying conductor. The strength of the magnetic field is proportional to the current. A changing magnetic field can induce a voltage in a conductor. This is the principle behind electromagnetic induction. Inductance is the property of a circuit element that opposes changes in current. Inductors store energy in a magnetic field. Capacitance is the property of a circuit element that opposes changes in voltage. Capacitors store energy in an electric field. Fourthly, alternating current circuits are circuits in which the current and voltage vary sinusoidally with time. The frequency of the alternating current is the number of cycles per second, measured in hertz. The root mean square, or RMS, value of an alternating current or voltage is the effective value that produces the same heating effect as a direct current or voltage. Impedance is the opposition to the flow of alternating current in a circuit. It is a combination of resistance and reactance. Reactance is the opposition to the flow of alternating current due to inductance or capacitance. Fifthly, power in alternating current circuits is the rate at which electrical energy is transferred. Real power is the power actually consumed by a circuit, measured in watts. Reactive power is the power that is stored and returned to the source by inductors and capacitors, measured in volt-amps reactive or VAR. Apparent power is the vector sum of real power and reactive power, measured in volt-amps or volt-amps. The power factor is the ratio of real power to apparent power. It indicates how effectively the electrical power is being used. Sixthly, power systems encompass the generation, transmission, and distribution of electrical power. Power generation involves converting other forms of energy, such as fossil fuels, nuclear energy, or renewable energy, into electrical energy. Power transmission involves transmitting electrical power over long distances at high voltages to reduce losses. Power distribution involves distributing electrical power to consumers at lower voltages. Transformers are used to step up or step down voltage levels in power systems. Circuit breakers and fuses are used to protect electrical equipment from overloads and short circuits. Seventhly, grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Grounding also helps to reduce electrical noise and interference. The National Electrical Code, or NEC, provides standards for grounding electrical systems. Eighthly, electrical safety is of paramount importance when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. Be aware of the hazards of electrical shock and arc flash. Ninthly, electrical codes and standards provide guidelines for the safe and proper installation and operation of electrical systems. The NEC is the most widely used electrical code in the United States. Other relevant standards include those from the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Tenthly, test equipment is essential for troubleshooting and maintaining electrical systems. Multimeters are used to measure voltage, current, and resistance. Oscilloscopes are used to display waveforms and analyze circuit behavior. Power quality analyzers are used to measure power quality parameters such as voltage sags, swells, and harmonics. Firstly, consider voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC specifies maximum allowable voltage drop for branch circuits and feeders. Secondly, conductor sizing is critical for ensuring that conductors can safely carry the intended current. The NEC provides tables for determining the ampacity of conductors based on their size, insulation type, and ambient temperature. Thirdly, overcurrent protection is used to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses are common types of overcurrent protection devices. The NEC specifies the proper size and type of overcurrent protection for different types of circuits. Fourthly, wiring methods refer to the different ways that electrical conductors can be installed. Common wiring methods include conduit cable and wireways. The NEC specifies the requirements for each wiring method. Fifthly, equipment grounding is essential for providing a safe path for fault current to flow back to the source. The NEC specifies the requirements for grounding different types of electrical equipment. Sixthly, bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to reduce the risk of electric shock. Seventhly, surge protection is used to protect electrical equipment from voltage surges caused by lightning or other disturbances. Surge protected devices, or SPDs, are installed at the service entrance and at sensitive equipment. Eighthly, harmonics are distortions in the sinusoidal waveform of alternating current. Harmonics can cause overheating of equipment and other problems. Harmonic filters can be used to reduce harmonic distortion. Ninthly, power quality refers to the characteristics of the electrical power supply, such as voltage stability, frequency stability, and harmonic distortion. Poor power quality can cause equipment to malfunction or operate inefficiently. Tenthly, energy efficiency is the practice of using less energy to perform the same task. Energy-efficient lighting, motors, and other equipment can save money and reduce environmental impact. Firstly, NEC Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting, and other loads. Article 210.8 covers ground fault circuit interrupter or GFCI protection, which is required in certain locations to protect against electric shock. Secondly, NEC Article 220 covers branch circuit, feeder, and service calculations. These calculations are used to determine the proper size of conductors and overcurrent protection. Thirdly, NEC Article 230 covers services, which are the conductors and equipment that bring power from the utility to the building. Article 230.95 covers ground fault protection for services, which is required for certain large services. Fourthly, NEC Article 250 covers grounding and bonding. This article provides the requirements for grounding and bonding electrical systems and equipment. Fifthly, NEC Article 300 covers general requirements for wiring methods and material. This article provides the basic rules for installing electrical wiring. Sixthly, NEC Article 310 covers conductors for general wiring. This article provides the ampacity ratings for different types of conductors. Seventhly, NEC Article 400 covers flexible cords and cables. This article provides the requirements for using flexible cords and cables in electrical systems. Eighthly, NEC Article 430 covers motors, motor circuits, and controllers. This article provides the requirements for installing and protecting electric motors. Ninthly, NEC Article 440 covers air conditioning and refrigeration equipment. This article provides the requirements for installing and protecting air conditioning and refrigeration equipment. Tenthly, NEC Article 500 through 516 covers hazardous locations. These articles provide the requirements for installing electrical equipment in locations where flammable gases, vapors, or dust may be present. The study of electrical theory is a continuous process. New technologies and regulations are constantly being developed, so it is important to stay up to date on the latest information. Online resources, trade publications, and continuing education courses can all be valuable sources of information.